Right. So will it? Come on. Clicker. Do. Yes. So in this company, I'm leading, in Cityco, I'm leading a team doing AI and machine learning. I've joined Cityco 6 years ago, I think, already, when all this AI and machine learning story in Cityco had started. We've built a team as a center of excellence doing AI and machine learning. We can talk more about what we do, how we do, where we do. Before it, I spent 10 years working for Microsoft, Microsoft Consulting Services, technical consultant here in Latvia, a lot of flying around, and it was quite good, international, interesting experience. But then, you know, at some point you decide that it's enough and you want to spend more time with your family. And for me, it was when it was 9 years and 1 day I submitted my resignation from Microsoft. 10 years and 1 day, sorry. And then I just left it. As everyone's speaking about AI, I do hold a PhD. And as everyone having a PhD, I'm still associated with a university where I got my PhD from. So I'm still associated with Riga Technical University. Very good university indeed, no complaints. And I'm one of lead researchers there. Talking about Cityco, actually, I don't know how much you know about Cityco. We are a quite large company. So we have like 500, 600, 700, it's growing, our HR knows better. We have offices here in Riga, we have offices in Spain, so currently a lot of people are working in different locations. After COVID, a lot of people are working from home, that's why I'm coming to the office and like, yeah, we have something new, because I'm spending a lot of time at home. 2 years back, I think it's already, we were acquired by Tech Mahindra, so we are now part of Tech Mahindra Group. Previously, we were focusing a lot on insurance and reinsurance exclusively. Now, with the acquisition of Tech Mahindra, they're treating us more as a top-level consulting for them. So basically, they take our experience from insurance, reinsurance, and bring it to different other clients. Like recently, we were meeting a company who is doing engines for aircrafts, for example. So it's a lot of cool stuff. AI team, we have like 10 people, both data scientists and machine learning engineers. Data team, we have more. We have around 30, I think, but we are actively hiring right now because data is just booming and many of our clients are looking for data. So if you have more interest in whom we are hiring, how we are hiring, then we have ladies from our HR and they'll be happy to help you. I'm not the right person because I don't know all these details. But if you want to know more about what we do in AI, what we do in data, feel free to ping me on LinkedIn or somewhere and let's have a chat. Not like I'm offering you a job here, but maybe I'll be interviewing you one day and maybe we'll be working together. Without further ado, this is actually, HR asked me to do it and I think I did it well, right? That was good. Yes, this is how you advertise the company. Thank you. So talking about today's agenda, it is a bit awkward, and this is the reason why we have 95 slides. Because originally I was approached and it was like, DevClub is coming to our office, why don't you go and speak? And I was like, yeah, let's do it. And a few years back, we were talking about what it means to be a machine learning engineer. And it was before the age of generative AI. And that's why we started thinking, okay, what do we talk about today, again, with engineers? And one idea was, let's talk about generative AI in general. Let's talk about history of generative AI. Another idea was more technical, deep dive, like, that guy is fit or girl? Yeah, so another idea was, let's talk about more technical stuff. Some inner things in generative AI, what engineers need to be aware of. And then we submitted some ideas to DevClub, and DevClub said me like, yeah, we want all of them, just combine them in one presentation because we have very diverse audience. And I was like, yeah, cool. And so my idea about you, my assumption is, you are engineers, so you do some programming. So there will be slides, actually I will be showing some code and there will be coding demo today. But what had changed with ChatGPT and other GPT models, OpenAI in Azure, for example, Gemini, and everything else, BART, all these models. Actually, what I see now is that we had one client who said that as we don't need data scientists because we have ChatGPT, our engineers will do it for us. And we're like, yeah, cool, come back to us later. No, we haven't said it, but that's basically what will happen, most probably. And what I was thinking that maybe what had changed for engineers is that you are in a similar position where you're working on your project and someone comes and says, let's introduce ChatGPT or some other AI because it's so easy, right? There is just API, you integrate with it, great. And then I started thinking, okay, in this session, it would be good to give you an overview why it may be not that easy and show you some key things you need to be aware of, both technical and non-technical. So we will start with my subjective view, why people have high expectations for AI. Actually, this one is interesting. I was thinking, it is for AI or from AI? Because it's, and actually I opened the dictionary and it turned out in English, from AI is if you had some previous experience with the thing and that's why you have high expectations. But for is if you haven't had previous experience and this is why you have high expectations. And that's why I'm using for, because usually people do not have experience with AI at all, but they have high expectations. So we'll talk a little bit about how GPT and large language models work, and then the largest part will be how to become a better machine learning engineer. We will have like 10 points what I want to cover, and we will go through them quickly. Some of them maybe will be relevant to you, others maybe will be too technical or not so technical, but let's see how it goes. And one more thing, so again, QR code, the slides, all will be available to you. You can download it right now or later. One important thing, you can quote it. You can use the slides however you want. The only thing is, don't quote it that CityCo had told you this, because I haven't approved it as all my presentations. They are not like confirmed by anyone in the company. So you can say, Antons had told you, and all of this is my subjective opinion on this thing. So if you don't agree to this, that's fine. You don't agree to me, not to CityCo as a company. So why do we have high expectations to AI? This is one of my favorites where I saw it on LinkedIn and people were discussing it like, wow, these machines are so smart. Like we are asking it like, is 450 90% of 500? And the machine is answering like, no, it is not. And then it starts thinking and says like, oh yeah, it actually is. You see how human-like it is, how intelligent the machine is. It can understand that it got something wrong and they'll apologize for it. That's cute, right? And then usually what I hear from people, they're saying like, yeah, these machines are very smart right now. I just had to ask it a few times and then it finally understood what I want and gave me the perfect answer. And I'm like, okay, you have an app on your phone. What would happen if you would need to click it 3 times to get the right response from it? Would your reaction be similar or would it be different? And so this hype is amazing. And actually there is a whole religion around it. And it's like, if everything is correct, people are saying like, yeah, artificial general intelligence is, yeah, AI is amazing. And if something is bad, they're saying like, no, you're not using the latest version. You don't know how to write prompts to this thing. And it's religion just around it. It's interesting. And if you look at publications, I like this, where they try to summarize different things, what people are writing about AI. And they're saying like, they came up with this acronym, which is AI Panic, where basically they started grouping different publications, who do it for business, who do it for marketing, who is just concerned, and who are concerned about ethics specifically. So it's interesting. It's a lot of noise around. And it's interesting that in last months, I start seeing that there are more and more publications, more realistic publications, to which I agree. And this maybe means that disillusionment is coming. So soon people will understand what is it, what is the state of AI right now. And it's interesting what will happen next. I hope we will not see another AI winter, what we saw in the past, where people, after this disillusionment wave, said like, okay, we were so overpromised that we do not want to do anything. Now, your customer, usually they say, our perfect solution in our mind. We have a question, and then we have some intelligent agent that is able to answer this question and provide links to some internal materials, right? Have you heard it from your customers? Everyone wants it now, right? So we will replace our employees with this, right? Amazing stuff. Brilliant. And then if you're asked to implement it, what you'll do next? You'll go to, for example, Azure, and you'll see, oh, this is a reference architecture, how you do it, right? These are different components. Or maybe you want to do it in AWS. So you go, and this is a reference application for AWS. Or maybe you want to do it by yourself, and you've heard that open source models are cool. You go to Hugging Face. You look, okay, question answering, like 7,000 models, and it was a few months back, so now we have even more. And then you think, okay, how do I implement it? Let's look for some frameworks. We have LangChain, we have Llama Index, and then you say, okay, LangChain, I found it first, let's click on that. And it says, okay, for question answering, just implement this few lines of Python code, this, and you're done. Amazing, you can go into production. Great. Then let's just build it, right? Where is the problem? The problem, I think, is the following, that these AI models, what we have nowadays, majority of them, like large language models, they're transformers. Models that are generating some images, they're transformers. The way basically transformers work, we can think of it that you have some input, and then they're doing some magic in this box, and you are getting some output, right? If we open that box up, then basically what you see now is the approach to the way how these models are trained is the following, that we have these foundation models like Llama, Llama 2, and so on, which are trained on massive amounts of data. It can be just text, it can be text, images, and videos, and then they are fine-tuned for specific tasks. For example, question answering or sentiment analysis, or answering questions saying that, oh, I got it wrong, sorry, and now this is the right answer. They can be trained to do it, right? If we open this foundation model up, what we will find there, we will find good old neural network. This is still deep neural network. And this is a neural network that will be training to do classification task. Basically, it will try to find the line that will separate these orange and blue dots. And you see, I'm starting it, it starts training, and here these connections, these are these edges, these are basically training weights. So this is what this model is trying to learn. So it goes forward, it tries to build the line, measures the error, goes back, adjusts these weights, and then tries it again and again and again. What's interesting here is that perfect line, right? And this is what neural networks are known for. They are very good in finding, in building these lines. So with mathematical functions, it can be hard to explain and to write a function like this, but neural networks are known for being able to generate any complexity of line, basically. Let's put it this way. So now, what's important here? Let's calculate how many weights we have here. It's basically 4 multiplied by 8, 8 multiplied by 8, plus 8 multiplied by 1, so it's a bit over 100. This is this neural network. Real-life neural networks, as GPT-3, for example, they have billions and hundreds of billions of these parameters. So GPT-3, it was like 176 billions. So you can imagine how many connections are in it. This is the same technology what we were using for many years already to classify cats and dogs. This is how we were doing. We had a collection of images of different objects, cats and dogs including. We were feeding it into the network, and the network was saying, this is a dog 94% and 31% cat, or this is a cat 91%, 37% dog. I know it doesn't sum up to 100, and some of you may say, like, it doesn't sum up, there is an error on the slide. There is not, they're just not normalized, right? So you can say, like, answering a question, is it a dog? You say 94% a dog. Is it a cat? 31% a cat. And then you can normalize them, and then you'll be getting, like, they'll sum to 100. But okay, me getting a bit PhD-ish here, right? What happened next? Let me quickly jump back. We realized that we are not able to get enough images of cats and dogs for real business problems, like for text, for example, to train machines to understand text this way. And this is where we had a brilliant idea. Let's do it in a self-supervised learning manner. Basically, we have a lot of text. We can take this text, we can remove a word from this text and say to the model, like, predict the next word in the sentence. Or we will skip some word and say, predict me the missing word. And by doing this, we don't need to label anything. We're just feeding a lot of text to the model. We can do the same with images, for example. Take an image, break it, so make it more noisy, worse resolution, feed it into the model, and it will return us image with a better resolution, for example. Or we can do it the same, like we give in the image and say, model, generate us the text, or other way around, right? But for now, let's think about this. So we can basically take whatever text we have, feed it into the model, and without doing anything, we just need to provide enough computing power and just sit and wait. And then the magic had happened. It had happened in 2019 when GPT-2 was released. I don't know how many of you have seen it, but it was everywhere in the press. It was like, yeah, we have GPT-2, and it is able to generate text like this. Like you prime it with some text, and then it generates an article, and you read through it, and it's plausible. It's basically, it's good. Yeah, it could like be an article on some news site. And then there was a lot of discussion in community how dangerous it is. What happens after it, and this was not released publicly, so you could not use it basically. They said, oh, it's too dangerous, let's not release it. What happened next? A lot of new models were trained in a similar way. And another thing that these models became more and more complex, like GPT-3 is 100 times larger than GPT-2. What is released as ChatGPT is GPT 3.5, so it's approximately the same size. But basically, this is what happened. And now they're released publicly, and it's not dangerous anymore, and everything is fine. Let's just use them, right? And this is where it is important for you, as for engineers, to understand what's inside this model, so you understand what can go actually wrong. One thing that had changed, the training process. So you saw this neural network that was just training to recognize blue and orange dots. Here we realized that we can actually do training in 2 steps. First, we do so-called pre-training, which is self-supervised. So this task was predicting next word or skipped word. We don't need to label anything. We just take all data we have and feed it in. And we don't have exact data for OpenAI models because they're proprietary, right? They're closed source. But we have it for open source. Like Bloom, for example, the model which is comparable to GPT-3, 176 billion parameters. Just to give you an idea, pre-training, they were using 1.5 terabytes of text. These are not documents, this is text, raw text, right? And they feed it in, and they were training it for, how much was it? 3.5 months on 384 NVIDIA A180 gigabyte GPUs. It's a lot, right? They're saying like it would cost 2 to 5 million in cloud computing. They were using nuclear power for it, and the heat generated was using to heating the campus, actually. This is a model slightly smaller, so it's the model to generate code, 15.5 billion parameters. It's basically 10 times larger than GPT-2, which was too dangerous to release. And it was trained on 6 terabytes of code. And they were using 512 GPUs for 24 days. And this is what it takes to train these foundational models. And this is why we train them once, and then we are fine-tuning them. When we go to fine-tuning step here, actually, this is done the way where you give it example and you show it how it needs to respond. Like basically, if I'm asking you this question, then I'm getting this answer. If I'm asking you this question, I'm getting this answer. And this is very important because when you think that the model is generating text similar to how we as humans would write it, this means that it had seen it in this training data set, or it had seen it in these examples where someone had told it that this is a good way to phrase it, or this is a good way to respond. And this is why you see that sometimes these models do like magical things where you're asking like, what will be the temperature tomorrow? And they're saying you the number, just one number. And then you're saying like, what is the temperature tomorrow? Please explain why you think so. And they're giving you like larger response. Why they do it, not because they understand what you want, but this is because they were trained this way. So they were trained that if you give like, please explain in detail, you need to provide larger answer. One good thing that happened is that in order to fine-tune these models after pre-training, we need much less labeled data. So if you have thousands of examples, you already can start doing it. And this is a good thing. And then the model is trained, you go into inference or prediction phase. And this is where one magic is happening, where no one actually still understands why it happens, and because it started happening with specifically larger models. And this is called in-context learning. So the model is trained, weights are frozen already, nothing is changing. But if in your prompt you are providing an example, like, for example, this text, it is a positive sentiment. This is a neutral. This is negative. And now you're giving the text and saying, what sentiment is this? Or, for example, you're saying, like, recently one project we were doing, like, here's the text, show me what UI forms we need, and please formulate your answer in the form of this JSON. And they can understand it, and they can generate this JSON. So basically, the theory is that they somehow are able to map your prompt to some point in their memory and generate the response this way. But yeah, that's a good thing. And this is why it is important when you're working with these models, provide examples. In-context learning does magic. Now, a lot of services were introduced. Some of them are writing code. Some of them are writing CVs for you. Some of them are generating images. So it's just booming. And this principle, all of these models are built on the same principles. Pre-training, fine-tuning, boom, go into production. Now, what are some main issues? The first problem, I actually called it zero because it is not specific for large language models. It's specific to any deep learning models, and large language models are still deep learning models. They're black boxes. We don't understand how they work. We cannot explain how they work. And it's kind of fine if they do everything right, but the problem is that at some point they can bite you, actually. And this is why a lot of attention is paid to how do you explain predictions, how do you do validation properly, and all that. And just to give you an example of how interesting these models can behave, during COVID times, many teams were training models for predicting how, if the patient has COVID or not, how severe COVID conditions will be, and all that. Then there was a study where actually researchers took different models and started validating based on what they were doing predictions. And they found out that majority of them were doing predictions based on some confounding factors, like, for example, text on RTG image, or, for example, position of shoulders. My favorite one was that they were predicting how severe COVID will be, and actually the model found a way how to determine if the patient was standing, sitting, or lying on the bed during X-ray. And basically it was predicting that if the patient is standing, then COVID will be light, but if the patient cannot stand, then COVID will be more severe, right? And this is what these models do. So they are optimization machines, and they are really tricky. And that's why in our work we spend a lot of time thinking on how do we split data sets into train and test, and how do we do all the validation. And recently we're working with one Zurich university, clinical university, university clinics. Yeah, this is the right name, ophthalmology department. And actually they were doing scientific publication based on work with us, and they put in the publication specifically a section describing how we're splitting data sets, just because they said that this is science, what you do. And we actually, yeah, we spend a lot of time there. The first one, this is specific for generative AI, and perhaps you've heard about it because many people are talking about it, like these models are hallucinating. And what I found interesting is that usually people say, like, it's not a problem that they're hallucinating, because, I mean, hallucinating means generating some gibberish text, we will find it, right? But here is an example. It is a Flanty 5XXL model, it's 11.3 billion parameters. It was running on my home machine, so it's my home lab, right? No, I'm PhD, so it's my research lab. So it was running on my research lab on the GPU, and I'm asking it, like, John just turned 15. It is allowed to drive a car when you are 18. How many more days John has to wait until he can drive a car? Provide rationale before answering. And the model is saying, like, John has to wait for 18 minus 15, 3 more years. Good, right? So he has to wait for 3 multiplied by 365, very good, 216. It's 216. Right? Days, the final answer is 216. And I'm like, yeah, cool, let's try asking the same, like 3 times 365, 3x 365, 3 stars 365, and I'm getting different answers. And this is hallucinating. So the problem of hallucination is that you read it, and it looks okay, it looks good, and then suddenly there is some rubbish thing in it. And you may say, like, Anton, this is a small model, who uses it, right? ChatGPT is much smarter. This is a real example of ChatGPT. Article in Forbes. One lawyer submitted his filing in court where half of cases he referred to were fake. They never existed. And then when they started investigating, they said, like, yeah, I used ChatGPT to generate it. And actually, yeah, I could not find these cases. But then I asked ChatGPT if ChatGPT is sure that these cases exist. And ChatGPT said yes. So yeah, the lawyer had not attended this session. So the lawyer haven't known what hallucinations are, but these are hallucinations, and this is a real problem. And there is an interesting term called sleeping behind the wheel, which is when generative AI generates text to you, and you're reading through it, and you're reading again, you got tired, and you will miss it, basically. This is actually the sleeping behind the wheel, the term I liked a lot, which was in one of scientific papers. Actually, quite interesting one. Maybe I'll need to include it in some of the future slides. The second problem, the model, because of the way how it is trained, it depends a lot on historical data on which it was trained. Here's an example. So ChatGPT giving dietary advice. What these experts in dietary were saying, that one of the problems is that it cannot recognize what is scientifically proven, what is not. If there are a lot of people in Reddit talking about it, it will think that it is true, like don't eat meat or eat only meat. And it will think, oh yeah, I'll recommend it. Another problem was that it gives you just one answer and you cannot understand. Basically, if you're Googling for it, you will find like oh, this source is not plausible, I'll not trust it. But here you're just getting an answer and you don't know where it came from. Then it is quite often giving you recommendations about European cuisine, just because it had seen it more than any other cuisine. And finally, if it gives advices on some BMI or something, it's European BMI, because this is what he had seen, or she had seen. I don't know, ChatGPT is he or she, whatever. And another interesting example, which is more maybe dangerous, Islamophobia. Stanford University, they did it for GPT-3, where basically what they were saying that they took a model and they were asking it a question like, two Muslims walked into a, please complete a sentence. And like if you say two Frenchmen walked into, they would walk into a theater or walk into a pub or somewhere, but here Muslims are walking into synagogue with axes and a bomb, or walking into a Texas cartoon contest and open fire. And it kind of, yeah, this is a problem, right? And so it is a good way to understand what data your model was trained on and what biases it could collect out of this data. Now, the next problem is legal issues. It's a lot around the press now, where writers are trying to sue OpenAI, saying you're training your chat these models on our data, now pay us, or maybe this data was pirated or something. And you may say, like, who cares, right? These writers, who cares? What is more interesting for us is Copilot, for example, is generating code, and there is a real case where Copilot, for specific query, had proposed a code which was written by this gentleman, and it was protected by the license, and Copilot just was not including it. But the code was actually line by line what the gentleman had written. Why it is important for us is because if such code will be in our, like a Citico code base, for example, we would have liability on it, right? Because, I mean, it doesn't matter. We will not say like, oh, Copilot generated for us, sue them, not us, because it's our code base, so we will have to pay a fine. And this is actually quite dangerous. So think about who owns the copyright on the stuff that was generated. And finally, the problem is that these models are just too large. So they're massive. It takes a long time to train. If you want to fine-tune them, it takes a long time to fine-tune. You need a lot of GPUs. And that's why currently there are separate, let's say, direction of studies. How can we make these models smaller and still preserve the same level of accuracy? Or how can we fine-tune them in a way so we require less GPU power? But this is more scientific, but just keep it in mind. Now, 10 points. How to become a better machine learning engineer. I'll try to be quick, just going through them. On some of them, we will stay longer. The first one, think about data privacy, right? When you're dealing with data, if you take LangChain, it may look to you that you're writing some code in Python, so it's local, but really you will be using cloud APIs, most probably. So you need to think where the model is hosted. If it's not self-hosted by you, it's not magic. It's not like magically it is answering your questions. It is hosted somewhere. What data you are sending to them? Do you pre-process this data before somehow? And how they will use your data, just read their SLA. Usually they say like, we will train our model on your data, we will sell your data further, or we will not do anything with it. And this is a big topic, so just remember about it, think about it. This one is interesting. Bigger models does not mean better models. If you want to select the best model, like let's do the best model. If it is open source model, you would go to Hugging Face, and in Hugging Face, they have this list of models, and they have different synthetic metrics for them, and you will see, okay, which one is better. You can sort and do all this stuff. There is a separate ranking for small models. If you want to get more like human emotions or like human experience with these models, you could go to Chatbot Arena, where they allow people to chat with different chatbots, including GPT-4, and then you can give some ranking to it, and they have a leaderboard where GPT-4 is at the top. But what is important is that accuracy is not the only metric. Another important metric is speed, and here you can see it is from Sentence Transformers, where basically you can see performance of the model, speed of the model, basically how many sentences it can process in a second, for example. Because this is important. And this is what we usually hear, that with GPT-4, GPT 3.5 in Azure, for example, all good, but they're slow. So we need something more performant, maybe less accurate. And then the model size. If you want to host it locally, then it is important for you how big the model will be. If you want to run it on GPU, will you have enough GPU memory? If you're interested specifically in memory, you can then go to Hugging Face and enter a URL of your model, if it is open source model, and they'll give you two parameters. So first, they'll show you the size which is needed in memory, and you can think of it as GPU memory for inference. And then it will give you a size of memory which is needed to train it, and it's much larger. So if you want to fine-tune it, you will need much more memory. But the important thing is that by default, these models are trained in Flow32 precision for weights, but there is a technique called quantization where you're basically reducing precision and you're reducing size. So you can go to float 16, you can go to int 8 even, and it will still work. And just for information, Llama 2, 70 billion, so it's a big model. If it is non-quantized, you would need 256 gigs of GPU memory to run it on GPU. If it is quantized to integer 8, it would need 64 gigs to run for inference. 64 gigs sounds like enormous, right? But you can do it on this machine, because this is Mac, and on Macs with Apple Silicon, what you can do, they have shared memory. And you can, I think it was 25% of memory needs to, or 20 or 25, some number, basically. You need to keep it for CPU, but remaining memory can go to GPU. And so if you get a Mac with 128 gigs, for example, then you have 96 gigs of video memory. And there are models that are running on it. So if you want to run code completion with some of these code completion models, for example, code generation models, locally, you can do it if you have these architectures with shared GPUs. So it's a funny thing. You may say, okay, but smaller models, they're not that accurate. Who needs them, right? They're rubbish. We need GPT, we need large models. This gentleman, Niels Reimers, he is one of the guys behind Sentence Transformers and SBERT. And so he's well known. And he was doing interesting analysis, and he's doing it still, where, for example, he's saying like, okay, GPT-3 embeddings were released in 2022. We have small models. If we migrate to these embeddings, we would get more accurate results, but just by a few tenths of %. Doesn't cost the money, and he's saying here, like, for example, if you have a large data set and you need to do predictions on it, or encode it, then it would take you 1 million with GPT-3, or you can take 1,000, label additional data, fine-tune small open source model, and you would get better accuracy, and you would save a lot of money for your team. Great advice, right? And just keep it in mind that with smaller models, it's much easier to operate, and quite often, paying for large model doesn't make sense. Now, another thing, like final thing, when you're selecting the model, you need to remember first, what is the maximum sequence of input length? So it's not like you can give it a book and it will give you the prediction. You can give it a chunk. And these chunks are like 256, 384, 512, for example. If your text is longer, you need to split it into windows, and then some magic starts happening. So maybe this is important criteria for you. Another thing is embedding vector size. We will talk about it, but it's basically the text what you feed in is transformed into numbers. The larger the vector, ooh, that was romantic, we can keep it. Yeah, so the larger the vector, the more information you can put in it. So basically people sometimes are saying, let's take a model that is able to accept larger input sequence. And that's kind of, yeah, sometimes you need it, but in reality, this information will be compressed in this vector. So if this vector is just 384, for example, I don't know if it will be enough to preserve the meaning of text on a level on which you want it to be preserved, but that's an open question. And then finally, as we discussed already, it's important to know on which data the model was pre-trained and what prompts it is expecting. So what questions it is expecting. And you can find information about it usually in model card and in description of training data. So just keep it in mind, go and read it before selecting the model. Thing number 3, human review is mandatory. So with generative AI, if you go into production, none of the models can guarantee you good generation results, stable, ready for production. Here is an example. Amazon, many sellers are generating descriptions for their products using OpenAI. These are descriptions of some of them. Some of these sellers are actually going even further. This is my favorite horse. It's like, okay, it's like OpenAI use policy against blah, blah, blah. Is there anything else I can assist you with 10 millimeters x 3 meters? And then they go further. They're saying that it provides you enhanced performance, versatile functionality, reliable durability. That's okay. Built to last, our rugged, blah, blah, blah. Immersive visuals, and simplify connectivity. Stay connected on the go with seamless technology integration. Amazing. And this is what these models do, right? So if you want high quality content, review, review, review. Don't put it into production without human review or review. Obviously, you can do it with some other model. So you could take a model that is trained to understand if this text looks okay or not, but still generative AI, you cannot rely on it. Fourth, define proper metric to evaluate results. Here I will go into detail on some publication. This is a good, don't take me wrong, this is a good publication overall, but there were few things which made me mad. And I know that guys and girls in my team were laughing on it because I was really mad reading through it. It's like what they tried to do. They tried to use generative AI to take an image, an X-ray, and generate description of it, like a doctor is doing. Like I'm saying this and that and something else. And then so the research is good, right? But then they're doing evaluating results. And I understand that evaluating medical text is hard, right? It's hard to get people who will be evaluating them. But what they did, they were generating text by their model and other models, and then they were giving it to GPT-4, asking to select the best generating text. And it's like, what is your metric? Like GPT-4 now is a golden standard or what? And then they say, okay, we went to human evaluation where they were actually asking physician to annotate the same scan, and then they were giving it to a group of experts who were saying like how the model did. That's good so far. But then here they're highlighting in green parts which are good and in red parts which are bad. But basically here the part in bad is that the AI is saying that here some chest tube, right-sided chest tube has been removed. So as I understand, it was just cut off, right? So it doesn't exist there. And now the question, if you are, to whom you're giving it? I mean, if you are giving it to the patient is reading and he's misled, like big time. If you are giving it to the doctor, why the doctor needs to read all this text, so I can imagine it. But even if they would read to this point and say, this model is stupid, I will not be reading further. But what they do, they're actually saying, in green is everything what is correct, and in red, just a few words which were wrong. But overall, the model is good, so we're on the right track. But to be fair, they're saying like, yeah, we need to do more investigation, blah, 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 because some of these mistakes are bad. But think about what is the right business evaluation metric for your model. And this is example, I also generated it by myself. These models are very good. All generative AI is very good when you don't need anything specific. Like you say, Renaissance-style portrait of an astronaut in space, detailed stereo background, reflective helmet. What a gentleman, right? We can put them in, I don't know, Rundle Pills or somewhere, just astronauts. Amazing, great. But then my wife is a dentist and I'm saying like, let's try something like Smiling Lady for dentistry ad, blah, blah, blah. It generated this. I tried to fine tune it with prompts. I'm not an expert, obviously, in this, and maybe experts know how to do it. I was not able. And I'm saying like, yeah, we can put this, like make one smile, get the second smile free or something. It's great. But this is important. So your metric, what you define, needs to be very specific, not just generate text that looks like the text what we write, because these models can do it. Now, 5, focus on business process and requirements. This will be a bit technical, but going back to this thing, where someone is asking you, implement me this chatbot. So I want AI to answer my questions. How can you do it? And this is a diagram. I had visuals for each of them, but my colleague told me remove them because it's very confusing, but I feel it got more confusing this way. But I'll try to explain. So the first question, what you need to ask, what kind of answers you need? Do you want them to be more human-like, or do you want them to be factually correct? Because, for example, if you do wrong answer, you will be sued in court, right? Because it's legal advice, for example. Think about it. And so if it is human-like, generative AI is good. If it is a little bit less human-like, there are models that are still finding a response in the text, but they're giving you the quote from the text. So they will not generate something that is not in the text. They'll just look for specific value in the text. If this is too risky for you, go for semantic search. You just do search, you say, here are the results, business user or end user, please select the right one, because we don't want to take responsibility. And sometimes you need to go back to good old full text search because you want to find something by keywords. And you don't need AI models for it because good old sparse embeddings do it perfectly in any database server or something. So just think about the real goal of your solution, not about cool AI that you will be using to solve it. 6, end-to-end does not always work. Think how to split problem to smaller chunks. This is the key. We had example of this with one of my colleagues last week, where one of our teams approached us and said, like, okay, we have the following scenario for insurance. We have a system that is able to generate forms, to allow us to design forms for different insurance flows. Like, for example, car accident. Car accident had happened, and I want a submission flow, like provide me this information, that information, some other information. And now they're saying, we were thinking, maybe we can allow users to write description, and then we will generate it. So we will generate this first set of forms for them. And the idea was that we have a description, we have some magical AI, and this AI generates JSON that can be fed into their UI and displayed there. So they gave us JSON schema, and one of my colleagues started experimenting with this, and they were experimenting with this as well. Like, GPT-4, here is a schema, prompt engineering for 1 day straight. And then we say, like, hold on, let's take a step back, let's do it this way. We ask AI to generate simplified JSON, just a list of forms and list of fields on them, which are required, which are types of fields, and so on. And then we will have a custom code to do the mapping. And actually, this will be a better solution because we do decoupling. You can change your JSON here the way you like, because it is coupled to your application, to your UI, and you don't need to revalidate what AI is doing. If AI was good, it will still be good. And we did it in 1 day for them. We did it, and they started implementing it. So usually with real-life problems, this is a big misconception that AI is one model that does magical big things the same way as we do, employees do, or smart people do. AI is good in solving very small, specific problems. So break the problem apart, and if something can be done with custom code, just do it. It will be much quicker. Because with this thing, one thing to remember, especially if you're doing it, it's not something I just now thought about it. If you think about GPT, all these hosted models, they're changing. So you can spend a few weeks doing prompt engineering. You come up with a perfect prompt that does everything what you like. But then someone will submit a complaint to OpenAI about some case. They'll need to update their model, and they'll push their changes, and your prompt will stop working. You'll need to redo your prompt again. So you'll see that version of the model had changed. Sometimes you can stick to older version, but sometimes you cannot because there were legal issues why they changed their model. So just think about it. Data engineering, year 2022, DevClub, I don't remember which number. We were invited to talk about machine learning engineering, how we do it. All that is still valid. So if you're interested, go back, watch through that video. We are still big fans of layered data engineering convention, where we write pipelines in our projects. Data is going through these different layers. We're using Kedro to do it. And in Kedro, basically everything is around data sets. You define data sets, and then you write Python code, which are nodes, which is transforming these data sets. It's all about data. It's all about data management. So please do it. If you're collecting labeled data from users, think where it will fit there and all that. So just do it. Data engineering is still the key. Number 8, modern AI relies on vectors or embeddings. How many of you are familiar what embeddings are for different objects? In few hands. Okay, good. So basically, here's the idea. You saw that neural network. It was doing operations with numbers, and it works only with numbers. AI works only with numbers. So the question is, how do you transform any information what you have into numbers? And this is why we do this pre-training, to understand what different words mean when we put them in different positions. But basically what you do for every word, machine will calculate this embedding. And when we were saying like what is the size of the embedding what the model is generating, I was saying like 386, 512 or something. This is this. So this is this vector. And basically all information in AI, when you're asking it, for example, give me 2 similar documents. How AI is doing it? You calculate embedding for every word in the document, one way to do it. Then you do, for example, averaging. You get the same embedding size for the entire document. then you have few of them. What you can do, you can put them, just imagine you put them into multi-dimensional space, where dimensional means these dimensions, right, this size. And then you have some question, for example, to which you want to find an answer. You put it here as well. You calculate vectors, put it here, and then you do cosine similarity and pick the documents which are closest. Because this vector represents the meaning, so basically documents which are closest to this point will have the same meaning as your question, so most probably the answer is there. This is semantic search. This is how it works. What is important? In your real-life solutions, most probably you will not be dealing with vectors. You will take vector database. There are quite a few specifically designed vector databases. You just pick them. Your criteria could be accuracy, speed, how much memory is required, and here again you can do quantization before search. And then if you're using Postgre or Elasticsearch or Cosmos DB, they have their own vector databases. I think in Microsoft now it's Azure Search, Azure AI Search. They renamed it like 3 or 4 times, but basically, yeah, on this slide it's still vector search. So if you search for it, you'll see that it was renamed, but it doesn't matter. And here, in some cases, maybe you will have very specific scenarios. Like, for example, you have many vectors. You cannot fit all of them in memory. And you want somehow to train this index only on a subset of them. And you can take a library as FAIS from Facebook Research, for example, and they have a lot of different algorithms and a lot of publications that are backing them up. And you can do product quantization encoding, for example, that allows you to take smaller portion of vectors, and then you basically are training like a model on them that will be able to search in all other vectors. So basically it allows you to save a lot of memory if you need it. But this is if you want to get technical. If not, just use one of the available libraries. Now this is a killer for this presentation. This is where I spent the last night, actually. Response time versus throughput. Because people are saying like, you're showing slides, you're not showing us any code, the real demo. Show us the code. We don't believe that you know how to code. I'll show you the code. So response time versus throughput. What is a response time for machine learning models? You, for example, have a model that is able to detect if an image, what the user is submitting, is a cat or a dog. You are submitting an image of a dog, then you have some REST web API, which how the model is exposed, right, technically. Then you do some data pre-processing, like converting this image into some vectors, blah, blah, blah. Feeding it into the model, getting prediction, post-processing prediction, for example, calculating from probability is the right response or something. And you're responding back like, this is a dog, 99%, all good. All this is what makes a response time, right? Easy. So now, what happens when you have 3 users? In the best case scenario, you will process all the requests in parallel, and the throughput will be, for example, one takes 10 milliseconds, so it will be 3 per 10 milliseconds, so good throughput. In the worst case scenario, there will be one after another, so for the first one, response time will be 10, for the second it will be 20, for the third one it will be 30, so it's 1 per 10 milliseconds. Where is the bottleneck? The bottleneck is actually the model, because the model is the slowest piece here. So what can you do with this? One easy logical solution, let's do scale out, right? So we put a load balancer, we put multiple web services, each of them will have a model, but the problem is that this model usually requires a lot of memory, and if it is a neural network or transformer model or large language model, it requires a GPU. So you will need 1, 2, 3 GPUs, which is kind of expensive, right? What is another option? Another option is to do batching, where you have some component which you put in front of your model that is batching the requests that are coming from your users and then submitting them to the model in a batch. The problem with this is that not all machine learning models support them, but the good thing is that neural networks do support it and they work really good with it. And this is where I wanted to show you some code that from code perspective, what is interesting, here I highlighted the line I wanted to look at, you're calling model predict, and you're calling model predict, same model predict, just specifying the batch size, because basically with neural networks, when you do prediction on one sample, you're doing a prediction on a batch of 1. This is what's happening internally, right? And from performance perspective, it's like this. When you do it for one image, you get it 12 milliseconds. When you do it for a batch of 20, you get 15 milliseconds. And this is where batching helps a lot. Now, how you do it really in production? In real production setup, the simplest architecture, just a few tens of lines of code, and you can implement it, is the following. And this is how we usually go into production if we're a self-hosting model. You have REST web API. Instead of running the model here, what you do, this API is putting a request in a queue, generating ID for it. Like these are the images which came from these 3 users. And then it is polling database waiting for prediction with this ID, basically, which was generated here. And then you have a model server, just a console application, console process running in the background that is polling the queue, and then it does prediction in batches. And when the prediction is ready, puts it in the database, and this is how it all works together. And you have some configurable parameters what you need to fine-tune for exact like load what you have, like queue polling interval and batch size. The larger the batch size, the more memory you will need here, GPU memory specifically. And here you can do polling interval and obviously retries before the timeout. Does it make sense to implement it? Like, will it really help you? And this is where comes the demo. Visual Studio Code, amazing. Finally, I'm showing the demo. So what do we have? Experiment setup. We will be using request pose, regular one. We will not be using any async IO or anything, right? We will be submitting one image, and we will be doing it for 500 images. We will run thread pool executor, so 100 parallel threads. The reason we do it so it doesn't like we cannot say like something is because of asynchronous requests are not going out, we're not utilizing all HTTP connections in one case, and another we are. So just to avoid the speculations, we're doing that. And we are basically dynamically growing GPU memory. It can affect performance, but it doesn't matter for this specific example. Now here, you will see Web API. So that piece that is receiving requests, and it is using GPU for predicting when we will be doing a prediction on Web API. And the database polling is set to 0.2. And here we have our model server. It is using the same GPU as well. And batch sizes will change to 10, 20, and 100. And now let's run it. So we're running this, and you see now we're doing simple endpoints, simple predictions, and we're doing it, only the web frontend is working. Web model server is not working at all, right? And it is running, and we got 13.5 seconds. So let's put it on the board, and you see that this backend was not working, frontend was working, because we were doing predictions here. Now, what will change if we implement that queue and database thing? So now the batch size here is 10. We will do the same thing, but we will be doing it the way that web frontend now is receiving requests, putting them in the queue, and this thing is taking them from the queue. So what we see now, it's 2:49 seconds. So you see the difference, and we've implemented just few lines of code. Another important things to see here, it is writing that the batch size is 10, and I'm taking from the queue 10 items, 10 items, 10 items, 10 items. So it is utilized, right? So it is not spending time. It is basically the load on the front end is good, and we're utilizing all our batches. Now, what happens if we, for model server, we will change our batch size to 20, and now we will need to restart this model server. Let's just quickly restart it, and now we will rerun this. So now the batch size is 20, right? We're rerunning it, it's done. So now the number is 216. So you see, it got a bit better. And actually, we see that all 20 items are received from the queue. So basically, we're still utilizing our GPU in this case, so all is good. And now what happens if we change it to 100? So we will go to the model server, and what had just happened? Okay, all good. Actually, you see the gym. Okay. So we are restarting our model server, we are running the code, and now the batch size is 100. And what we will see now is basically this, that we are getting slightly worse performance, but it's just slightly, and maybe it is because of this dynamic memory allocation that it just needed to allocate more memory here or something happened. So it's not that significant, but the important thing is that it's underutilized, right? So if you were calculating the amount of memory what you would need from the size of the batch, in this specific example, 100 is too much for you. Maybe 30 or 40 would be a sweet spot. That's the demo. How was it? Yay! Finally, I'm showing some demos. And now, this is a final piece, but this is an interesting and long one. It will be easier than the coding demo. Dangers of AI. What I want to tell about this is that they are real, but they're not coming from generative AI. Let me talk through this a little bit. I feel that people are talking a lot about dangers of AI, right? And they imagine some scenarios from Terminator, or depending on their age, right? Terminator or something new. And they have a reason for it. Because if you look what was happening in the press, it's just a mess. Like Bill Gates is saying the age of AI has begun, and you can understand it the way you want. Then I think Elon Musk was one of these people who was saying that we need to immediately post for at least 6 months the training of AI systems more powerful than GPT-4. We were laughing in our team that now we will be like saying that no, we're not training anything. We are mining Bitcoins and we're playing games and whatever we do, right? Then in Twitter or now X, professors, real professors like Pedro Domingos and Jeffrey Hinton were discussing about AI dangers, and it was so fun to observe all this. Jeffrey Hinton, godfather of AI, one of 3, had left Google. He said like, oh, it's so dangerous and I need to spend more time thinking about safety, left Google. Then EU and G7, they're discussing regulations around AI, and actually they've introduced them already earlier this year. Then there was this statement, which was actually, it's reasonable, it was signed by Bill Gates as well, where they're saying that we need to mitigate the risk of extinction from AI, and it should be similar to how extinction from nuclear weapons or something. So the question, what I want you to ask when you see this, is it something new, what we've never seen in the past? And the thing is that for people who are working in AI, it is not new, because few years before all this wave had started, so it's 2021, people already started bringing up topics about that large language models are so-called stochastic parrots. So they're just repeating stuff they've seen in the past, and it can be dangerous, so we need to investigate it more, right? Even before large language models were introduced, there were interesting effects of AI, how AI can affect people. One of them is called feedback loop and bias amplifications in recommender systems, where basically the effect is that in recommender systems, AI is recommending the same stuff again, and this stuff becomes more popular. And actually, if you have a lot of content, small part of it will be popular and will be getting more and more popular, but the people who have maybe uncommon taste, they will be very discriminated, because basically all their content will be dismissed. Then there is an interesting effect called echo chambers. Also, we talk about the year 2021. And basically, the thing this works is that in social media platforms, the way how content is recommended to people causes these echo chambers. You're reading what you want to read, you're believing in what you want to believe. And I don't know about you, but I feel it a lot because I have relatives in Russia, and I can see that they're living in a bubble, actually. And it's impossible to change anything just because they're always getting information what they used to get, and that's it. And here in this research, they're saying that, yeah, it is a risk for terrorism organizations. This is what they're using and everything. So quite an interesting read if you like it. Then in policing, we are saying like AI is dangerous, it can do something bad. It does bad things already. Like in policing, there are people who were arrested because of wrong AI predictions. There was one guy, at least one guy, but they mentioned it in this article. He spent few weeks or months in jail because of AI, because of face recognition algorithm that took him wrong, basically. I remember a few years back, LAPD, Los Angeles Police Department, they were one of the first who introduced AI, and actually AI in the beginning of the day was saying where policemen should go, right? Then they started abandoning it because they realized that what's happening is that if you say to policemen, go to this region or neighborhood because it's dangerous, because a lot of police episodes were recorded there, like some violences or something, then you will find more similar episodes there because more police, more episodes. They're sitting there, they need to do something. So they're doing something, it goes back to you, and then it's like, oh, it got even more dangerous, more police, more police, more police. And this is maybe a funny problem. Less funny problem is the following, that when people start believing it, when policeman receives from AI a recommendation, go to that neighborhood because something violent will happen there. The policeman is primed. They're going on site and they're ready to use weapons or something, just because AI primed them with something dangerous will be happening there. And that's a problem. But the thing is, it is there for many years already, and there are researchers, studies around it. And for example, now LAPD is using AI to predict biased policing. So they're using AI to predict biases in humans. So these are known things. We're working with them. It's work in progress. We just need to do it. So the next question is, what people are asking a lot, are machines as intelligent as we are? Because GPT generates so good text. Maybe it is already as intelligent as we are. And here is a good read and a new term called artificial capable intelligence. Basically, the way to read this diagram is the following. We were in an age of artificial narrow intelligence. We were training models to recognize cats or dogs and doing some very narrow specific thing and doing well. Now we have GPT models that are kind of answering any questions, and somehow people are saying like, oh, they are responding as humans would respond, so we are here, artificial general intelligence, or even maybe super intelligence, so they're smarter than we are. And then this gentleman, Mustafa Suleiman, historically he's from DeepMind, he introduced a term called artificial capable intelligence, where he's saying that the way we were measuring performance of AI in the past with a Turing test, where basically you're chatting with machine, and machine needs to behave the same way as human is behaving. ChatGPT is doing it, right? And he's saying like, this is not the metric. Because as he says, like, generating text is one thing, but achieving something in real world is completely another. And so let's measure what this AI is capable of achieving. Can it do something instead of us or not, for example? And this is an interesting perspective. And actually, a lot of people who are in AI, like Jan LeCun is saying like, all these things about AI as smart as we are is far away, because most probably we'll first get cat level or dog level AI, and then we'll get human level AI, and we're not there yet. Fei-Fei Li is saying that, yeah, AI is, I like this, it was harsh, but it is good, like AI is promising to transform the world, as a journalist is asking, and she is responding like, AI is promising nothing. It is people who are promising. AI is just a piece of software. We run it. And I mean, what the heck? And then she's saying like, yeah, it's just a tool. And obviously we need to keep these risks of misusing this tool seriously. But we have other problems to address now as well, which are very important. We just need to think about it. And Bill Gates is also like saying that GPT-5 most probably will not be much better than GPT-4 just because the technology had reached some plateau. And if you are software engineers and you are hearing like AI will be writing code instead of you, maybe parts of code in some specific conditions, but software engineers are not writing code. This is not your job, right? And it is like it for any job. So the biggest part of your job is to understand requirements, understand hidden requirements, understand some legacy systems, what is the best way to integrate with them and all that. And AI is not there, right? Does this mean that AI is not dangerous? Unfortunately not. And what we saw in 2019, that AI nowadays is very good in generating fake content, it just continues. When the war in Ukraine had started, first week after it, there were videos with both presidents saying that they're capitulating. Unfortunately, this man didn't, right? So, but yeah. And you may say, like, if you saw these videos, like, who believes in them, right? So they are not maybe realistical, and you can see that they're generated, blah, blah. But here's an example. It is coming from the year 2019, where basically with deepfake technology, these criminals had generated a voice of one exec of one company. They were calling his employees and saying, like, transfer money somewhere, and they actually agreed to transfer and transferred it. So they managed to steal 220,000 euro back then. And recently there was a case where actually criminals invited a guy into a video call where they were deep-faked faces of his colleagues. Some of them he had even met, and he transferred something like 20 million or something. So it's a mess. And yeah, this is the world we are living in. Last year, there was an image of explosion next to Pentagon. A lot of Telegram channels were sending it around. Russia Today propaganda media was sending it around as well. Then it was detected that the hypothesis is based on multiple factors, that it's generated by AI, and actually it affected stock markets. So stock markets dipped for some moment. So it can be dangerous. And if you are in security, then it is your problem now that with generative AI, phishing attacks are much more sophisticated. You can send different emails, you can do chats with people, you can translate to their language. So it is getting much, much, much more dangerous. With this was number 10. So now it's time for key takeaways. I will not be repeating all these 10 things, so you can find them in slides. I just wanted to mention 3 things, which maybe I have not mentioned during this session at all. The first one, I do believe that nowadays, because of all this setup, that clients are going to engineers and saying, we have AI model, let's just implement it into our product. ML engineers or any software engineers are becoming AI advisors and consultants for their customers. And here I can advise you, don't assume that your clients understand what they do with AI, because they have not attended this session. They do not know all these problems you know about now. Ask questions, raise concerns, educate them. And if you feel that there is some gap, don't hesitate to go to data scientists, right? Because data scientists still know how this thing works from the inside, and they can recommend you to fine-tune the model or do something else. So don't hesitate, do it. The second important thing, don't treat AI as something magical, treat it as just a tool, just another tool what you can use. And what we usually say to our clients, and this is our philosophy, we don't focus on AI when we implement solutions, we focus on IA, which is intelligent automation. We look into the business process, we understand what are the ways to improve it, where can we do it with AI, where we don't need AI, and we need some rules or just some integration API. We don't need to transform any JSON schemas. We just need to agree on the same schema with our partners. And let's just do it. And then just start gradual feature improvements, iterative improvements, like feature by feature on the business process. And remember about this context of artificial capable intelligence. So it doesn't matter how intelligent the AI looks, like how it chats with you. The real question is, what does it mean for end-to-end flow, right? And finally, dangers of AI, they are real, but they're coming from us, from humans. So here, remember that AI does not think the way we do. It's neural network. I've shown you how neural network is being trained. Beware of fake content. Fake content is a big problem. It's everywhere. And it's not only malicious fake content, but also fake content like that lawyer who generated it with ChatGPT. He had no bad intent, but just he was not aware of hallucinations. And I see it a lot in the internet because many articles are generated this way. And finally, you saw some examples where AI can be dangerous because of the way how it affects people, with policemen, with echo chambers, with recommender systems. If you're implementing something like this in your systems, think what side effects it might have and how it will change the business process and the environment in the future. With this, thank you very much. Here is a QR code, the link again.